Welcome, Calculus BC. This is 7-3 Convergent, Divergent Series, Geo Series, and the nth term test. We're in BC land, folks. So, when you see these notes in the future, red box things are really important. You're going to want to write them down because those are formulas, and you're going to reference those later. So, let's begin. Series, last time we talked about sequence, and so a series is the sum of the sequence. So, you add all those terms up. So here's what it'll look like. Remember that friend summation notation? We're coming back to that. So when I say the sum of some a sub n, that's the formula from n is 1 to infinity. A lot of time we're talking a sequence, we're talking about an infinite series. It grows forever. It's a sub 1, a sub 2, a sub 3, add them all the way up till a sub n. So add up all those terms to go to infinity. And like what happens when you do that? So let's take an example right here. What happens in this one? We have n is 0 to infinity, 2 of n plus 1, which would be 1 plus 3 plus 5 plus 7, and so on. Well, what's going on? Well, they're just going to basically add up to infinity. It keeps growing. It keeps going more and more and more, and it's going to add all the way up to infinity. So that's important to note here. Like, what is going on with these kind of sequences with that one? Well, let's look at this sequence. What's this one do? And what happens when there's more and more terms? So let's start counting them out. 3 over 10 to the n power, so that'd be 3 over 10 to the 1, or 3 over 10, plus 3 over 10 squared is 3 over 100, plus 3 over 1,000, plus 3 over 10,000, and so on. If you actually do that decimal, that's 0.3, that's 0.03, and so on. So it's actually 0.333 repeating. So the sum of this is actually, when you add all these up, because you're actually adding some small, it's actually 1/3. So even if you go out to infinity, where the last one just kept growing forever, this one you're adding smaller and smaller numbers, so you can say the sum is 1/3. And this is an example of a convergent series. Can remember from last time, convergent goes to a number, divergent goes up to infinity. So convergent geometric series. So just a note, series will either converge or diverge, and different rules from sequence. And there's going to be a bunch of different formulas that we're going to have to do. And so make sure you write these down nice, and we'll memorize them, and you'll definitely come back to this. So here's the first one, geometric series. So this is a pattern you might have seen in Algebra 2. And the sum from 0 to infinity, well, if you remember summation notation, a times r to the n power. We call this geometric. Geometrics, usually like we're multiplying a number. So where a is going to be your first term and r is some kind of ratio that you're like in ratio to the n power. So the first term is a plus a times r and r squared and so on. So these are called a geometric series. You're basically multiplying a number every time. So if the absolute value of that is greater than or equal to 1, the geometric series diverges. If r is absolute value is less than 1, geometric series converges. So basically, if it's like a fraction between -1 and 1, it converges. So like if r was 1 over 2, or like 3 over 4, or like -7 over 8, these would converge. If r was like 5 or 1, or like -2, or like -5/4, these would diverge because these are all greater than 1. That's a fraction greater than 1. And if it does converge, we actually have a formula to tell what it's going to actually add up to. It's a over 1 minus r. And again, you might have seen this in Algebra 2, or you probably forgot, but it was there. So let's look at some examples. Actually, we can go back to that previous one we just did. 3 over I want to do this one, 3 over 1 to the 10 power. Now, remember, your formula is a times r to the n power. So the goal is to get this into something that looks like that formula. It doesn't quite look at that formula because that's like 10n on the bottom. What I'm going to redo is I'm going to rewrite this as 3 times 1 over 10 to the n power. And this is like 1 over n, because 1 times n power is still 1, over 10 to the n. So I can actually rewrite this as 3 times 1 over 10 to the n power. So 1 over 10, that means my r equals 1 over 10. And since r is between 1 and -1, we could say this converges. Well, what's the formula for convergence? Again, it's a over 1 minus r. So the formula is, so we could say the sum is going to be a, which was 3 over 1 minus r, so 1/10. So it'll be 3 over, that's 10/10 minus 1/10, that'd be 9/10. And 3 over 9/10. So 3 divided by a fraction, same thing as 3 times the reciprocal, or 3 over 1 times the reciprocal, 10 over 9. and cancel a little bit, 1 over 3. So we're going to get 10 over 3. So that's basically what is 3.333. I kind of messed up a little bit. This one started at 1. Yeah. Oh, why did we get n equals 1? Yeah, so that's your answer. Oh, this is assuming you're starting n at 0. And we started that other one at 1. That's why. It's okay. So that's one thing to note as you're doing these kind of problems. So let's look at this. So again, we have to convert these. And this one, it's a very similar concept. That's like 3 times 1 to the n over 2 to the n. So I can rewrite that summation notation as 3 times 1/2 to the n power from n equals 0 to infinity. So again, this is going to converge because my r is 1/2. What's it going to add up to? So I'm going to say my sum is going to be a, so 3 over 1 minus 1/2. So 3 over 1/2, which is the same thing as 3 times the reciprocal, 2 over 1, which will be 6 if you added that up. Let's look at this one. In this case here, it's already in geometric form. Your a is 1 in this case, but your r is 3 over 2, which means it diverges. It's too big. Now this last one. Okay, so my n equals 1 is a little too big here. So what do you do in those kind of cases? Well, let's work out the first few steps of the pattern. If n equals 1, so I got to rewrite this a little bit. I know my r is going to be negative 1/2. All right, and the first few steps of the pattern are going to be negative 2 when n equals 1, and it'll be plus 1 minus 1/2 plus 1/4, and so on. So my first term of the sequence, remember it was their a is the first term. That's where I messed up last time. So my first term of the sequence is I'm starting at 1 is going to be negative 2 when you plug in that 1. So your sum, you know that it's going to converge because r is negative 1/2, is going to be negative 2 over 1 minus negative 1/2, which will be negative 2 over 1 plus 1/2, which is 3/2, which will be negative 2 times the reciprocal 2/3, which will be negative 4/3. And that's what it adds, and that's the sum of that infinite series. So again, converge, diverge, converge, and here's what it converges to in those cases. All right, so in general, so convergence of a series is kind of less simple than convergence of a sequence. These are kind of harder to do the series. Stumbled with that a little bit, but you know, there's a difference between converging a series and a sequence. We're not just looking at the last term; we're looking at what they all add up to. So one other thing to note is that certain sequences do not converge, and a series do not converge, and a series cannot converge unless the terms actually approach a limit of 0, and which comes into our next test. This is test number 2, the nth term test. So if the limit of like the formula is not equal to 0, then that sum diverges. However, the test is inconclusive if the limit approaches 0. So I can tell if something diverges, because if the limit doesn't approach 0, it will diverge of a series. However, it can't tell if it actually converges. I only can tell if it definitely diverges. I'd have to use other tests later. So what does that mean? Let's do this example here. I don't really like this example, but whatever. So we're going to use the limit test in this case. As n approaches infinity, of the formula n factorial over 2n factorial plus 1, that's 2 times n factorial order of operations. So it's not 2n factorial, it's 2 times n factorial. So what's this going to look like as you go to infinity? Well, you'd kind of think L'Hopital's rule about how do you derive a factorial, and you can't. Let's just look at this a little bit logically here. As you grow up to a really, really, really big number here, this plus 1 just doesn't matter because like n factorial grows really fast. So doesn't matter. So basically I have n factorial over 2 times n factorial. And well, if n factorial are going to cancel, so I'm just left with 1/2. So the limit is actually 1/2, which is not 0, so it diverges. If it was 0, all we'd say is, well, we don't know. We have to use a different test. All right. Okay, we're going to go over this in class. I think I want to cut the video here, but well, just really quick. Sequence versus series. How do you tell convergence? Like, I'm getting confused now. Well, series Sequence, you look at the terms, and you're looking at the last term as it goes to infinity. And series, you're looking at the sum of the terms. Okay, so series is sum, sequence is just the terms. I think a lot of times we're actually going to be doing series in this class, not sequence. And then, what tests do I use? This is going to be a big question you ask as we learn more and more. So we've learned 2 tests. We've learned number 1, call that geo. We're going to call this one number 2, the nth term test. And as we get more, you'll see we'll have a chart. But so if it looks like a geometric series, then use the geo. Otherwise, you're going to use the nth term. So as you're doing your homework, does it have to the nth power? So like some a to the nth power, that's a geoseries. If there's no nth power, it's probably the other one. All right, that's it.